record, recording in progress. And then chess clock, there we go. So just for everybody joining for the first time, the format is that on my computer, I'm going to be running a chess clock. So that's two timers up, one of them with 7.5 minutes, the other one with 7.5 minutes. As the presenter is presenting, at any time, you can interrupt with questions if you'd like, and we'll pause the presenter's time and switch over to the audience time, which is the other clock. And as soon as the question is answered and we get back into the presentation, I'll switch the time back over to the presenter's time. And so that way, the presenter is guaranteed to have 7.5 minutes of time to share their work, and the audience is guaranteed 7.5 minutes to ask questions whenever they want. If we run out the clock on one side, we'll just start eating time away from the other side. And it's all, it's all good. We're all friends here. That's the format. And yeah, Marek, by all means,
Nice.
kick it off whenever you're ready.
Okay, so I'm going to talk about automat. And I used to talk about automat a little bit, but I usually do my presentations like that when I just talk about the problem, and I avoid talking about automat as much as possible. But because this is a very different audience, I decided to kind of include some of the solutions for the problems that I'm kind of presenting, and also show a demo of the project itself. So recently there was this discussion on Slack about what problems are we trying to solve. So this is my formulation of the problem. So it would be nice if programming was easier. There are two things that we could take out of this. So first of all, if programming looked like a game, if it was actually entertaining, it could be like a casual activity. It could be something that you do with a gamepad. Or if you know esports, I used to attend some competitions and they are super fun, but they are not very photogenic. Like you cannot record and do a broadcast from a programming competition. I think if the interface to programming was a little bit nicer, something else instead of text, because behind this text, there is actually a pretty fast-paced action. There is stuff going on all the time. It's not very understandable to bystanders who are not familiar with this stuff. So that's one. It could be more fun, but it could also open this field to a lot of people who have computers in their phone pockets. Kids, older people. I actually think when you actually think about what would ordinary people would want to do with computers, it's most of the stuff that they would like to do are very simple, step by step, just following the same sequence of execution. And most of this stuff, we don't really need any languages to do this. Following a sequence of simple tasks is something that we could do with Scratch or other stuff like that. So I will show you a demo of the program that I'm making. So this is a canvas-based app. It looks like that. We have this rectangular canvas, and on this canvas we can put objects. Those objects react to mouse input, and they can send signals to one another. So here I can delete this stuff. An object called macro recorder that can record macros. When I start it, when I press some keys, it takes care of this macro recording process. And this is an interesting object because it's actually managing other objects for you on this canvas. Because theoretically, you could create a timeline and connect everything up. It's much more convenient if you have an external object that will do this for you. When I play this, it can actually send signals to the key objects here and drive their execution. Other objects like a timer, they can be hooked up in loops, which actually look like loops and react like immediately to stuff that I'm doing. I'm not going to show everything. It's just for illustration purposes. So this application here, okay, maybe at the end of presentation, I will talk more about this. So the key idea here is that I will talk about some kind of key idea. There is no single key idea, right? If I would summarize Automat as a single sentence, it would be a multi-paradigm object-oriented interface. Let's start with object-oriented, because we all learned about what object-oriented means. I actually mean it here in a very specific sense. So in my kind of view of object-orientedness, the code, like objects, should correspond to code, not to the data. So the data that program encodes, the program can encode it in using whatever means they want. It can be encoded as binary data in memory, as SQLite database, as text files, JSONs, XMLs. The objects are code. They are the interface to the underlying data. So in any Automat program, you would see a fixed constant number of objects that in the same way that in a source code, you have always a fixed set of source files. If you have more data, you don't need to add any extra source files to your program. A program with fixed amount of instructions can work with arbitrary sized data. So an object would correspond to a struct. Here, for instance, we could have an object that corresponds to like this particular struct that could be used to, for example, to allocate objects like buffers in memory with this memory layout. But the buffers in memory, they are not objects. They are just stuff in memory, which is managed by an object. So not everything is an object, like often we see in like object-oriented design. So next we have interface. Interface means that things in Automat are not only responsible for doing the work, but also they should care about presenting the stuff behind the scenes to the user. So using whatever means necessary. Animations, shaders, 3D objects, anything. The objects are arranged on a canvas. Like in the program that I showed you, they have shapes, position. The objects know what other objects are around them, and they can, for example, schedule stuff according to their like relations. Like objects which is on the top could schedule objects below to execute next, or they could look around in a fixed range for their arguments. And the interface layer is actually just a like layer on top of the like computational, say, core, so that it consumes a lot of resources, right? Rendering this stuff. But we only need to render stuff that we are actually seeing on screen. Like this is right, fairly obvious. This is what all games use, right? The stuff that's behind the scenes, you just don't render it. It can exist, it can work, it can like do its job, but you just don't need to render this. So
I'm going to jump in here. We're now out of presentation time and burning audience question time, but if there's no questions, then you can continue presenting. That's totally cool. I have like 100 million questions about the user interface because that's the stuff that it's like unbelievably juicy and so tactile and lively and animated and all of that. But I'm curious to hear more about the stuff you're talking about right now with the object orientation, the way data is handled, all of that, because that's the stuff that doesn't come across in all the GIFs and cool videos that you're sharing. So yeah, I vote keep going.
So I can actually share like the tricks that I use to render this stuff. I think I mentioned this. So the key technology is the rendering library, which is used by Chrome.
Mm-hmm.
This is Skia. This is Technically, it's written in C++, but there are bindings in basically every language. I kind of checked. There is Lua bindings to this. There are Python bindings. Flutter is another, like, so Dart can also interface with this. JavaScript, obviously. And so Skia, like, the crazy thing is this is the same stuff that powers HTML canvas. So theoretically, if they just opened the API, for example, for shaders, this would be totally possible from JavaScript.
Mhm.
Um, but okay, I will go through the presentation, then we can do the topics. So we had this interface, right? Multi-paradigm means that, so we have those objects, right, which are kind of arranged. The objects themselves, they don't really have to follow a specific kind of idea of how execution should be scheduled. So there could be procedural objects, there could be like functional objects, there could be macros in this like graph, like visual world. There is this concept of graph rewrites. So if you imagine a Lisp program, I would like the Lisp program to be directly, translatable in Automate. Like message passing, obviously, this is like the most old school one, rule-based, reactive, whatever. So I often see like many like languages, not only visual languages, just all languages, they often like pick one, let's say, idea of how we should build software, and they try to stick with it to be like super pure, like functional. And those systems are always very interesting because they are kind of pushing the boundaries. But from the like practical point of view, it often just makes sense to mix and match, whatever is best at a given point. So there is one more thing in Automate. This is, and then a couple more. So interoperability, following this wise thought of doing the most, having the most effect using the least amount of work. So instead of implementing like all of the basic math in Automate, Automate doesn't have any math objects. Instead, it relies on, for example, to do stuff on your desktop, it relies on driving external programs. So it sends input to other programs. And user is actually the one responsible for automating the programs in Automate. Um, so automation of desktop programs, this is roughly implemented, like keyboard, mouse are roughly working with big gaps. But as time goes on, I think there could be a decent interface for like regular users, like not programmers, to open and call just random C libraries. They are not that hard really, like behind the scenes. And I don't think it's like, I don't think it's too hard for regular users to open a DLL and call functions from a DLL. We could embed interpreters like Python, JavaScript, Lua, Bash, so that because those languages exist and they probably do their job better than we could do visually. So why not have like just a terminal object that could like run any of those languages? And I like kind of doing low-level stuff in memory. So I'm really gravitating towards more like low-level tools. For example, like for generating assembly programs, because we could just compile assembly and execute it. We could execute assembly right in a visual environment, but the assembly itself it would be nice to have just a decent interface to build assembly programs. Yeah, and others. So with Automate, I'm trying to make this efficient, so it's implemented in C++. I tried Rust. It was too hard. So it's released as a single executable. It's around 10 megabytes. I think it's a good target to keep it under 1 gigabyte. There is still a long way before I reach 1 gigabyte, but it's a ceiling for me. So I'm trying to carefully manage dependencies, make sure that I'm reusing stuff when I'm like pulling a dependency. I'm rendering stuff with Vulkan and Skia, like I mentioned.
I got a question.
Hmm. Um,
Yeah, I think the penny just dropped for me then. So is it the target for automation of other programs? Is that the domain you're attacking?
yeah, so there are two goals. There is the long-term goal, which is just a fun environment where I could kind of program computer very quickly, rapidly, get immediate feedback. Something that I could use if you uh, uh, when I mentioned competitive programming, this is actually the like original motivation for it. When I was like at competitions, working in C++, I think it's good to have like immediate feedback when you are working on something. So I the long-term goal for Automat is to be this uh, high performance, fast-paced development environment. But the short-term goal is to just automate apps. So mostly games actually. So it's actually not really meant for like business software. It's mostly meant for grinding levels or gold in MMO games. Yeah. Does that answer your question?
Yeah, brilliant. No, that's great. I think that's super interesting.
We're pretty much out of
And
time. But if you had like 30 more seconds you wanted to run through, go for it.
any parallel. Yeah, and it's free. I think there is a lot of like I think a lot of situations where we lack trust in software that we download from internet is because there is like an underlying like most of software expects to make money eventually in the future. Automat doesn't. So I think it's a hobby project, free, and it can be used commercially by other people if they want to. And that's it.
Nice.
Yeah.
I'm yeah. I'm so interested in this project for the very shallow reason that the visuals are incredible, and it's been so fun to see you adding new things to it and
It's
continuing
fun.
to work on this
So
and
so
evolve it.
it's often a little draining to spend like 2 weeks working on like a single animation. So that
Uh-huh.
it's very nice to hear that.
Yeah, you have such an incredible sense of style and flourish, and yeah, it's cool to hear that there are goals for this as a not just as like a demo of interesting visuals in a canvas, but also as a computable environment. So I'm looking forward to the next time we get to have an update on how that's evolving. Thank you. Next up could either be me,
I'll
yeah,
go,
I
but
or Daniel.
if,
Yeah.
yeah, I'll go because I'm just waiting.
Do it. Yeah, let's do it. Go for it.
Okay, so I'll share my screen. Okay, here we go.
Oh, and just before you start, one thing
Yes.
I forgot to mention at the top, I have to get a better spiel going.
Mm,
Um, it really helps if you spend the first 30 seconds or so saying, here's what I'm building and here's the problem it's meant to address. Like, here's the context of the work. Just do a little bit of kind of setting the scope so that we can understand everything that comes after that point in the framing of, here's why I'm building this.
okay.
It's a toy for worms to play with because worms get bored living underground
Okay.
all day. And so I made them something,
Okay. Well, I'm not going
etc.
to do it. I'm probably going to extend the reasoning behind it. And please, by the way, I won't necessarily see your hands up, so please do butt in. Just ask questions. I really work well under questioning, and it's a bit freaky to try and just reel off stuff. But I'll try. Kendra, it's a long-term project. I started it in the mid-90s. And we were always interested in interoperability, and this is the team as it stands right now. We've got a few developers and a few outreach marketing people. We are non-profit and open source. We raise money through philanthropy and research grants. So we were always interested in interoperability and how open protocols could allow data portability and freedom essentially for people to create the kind of worlds they wanted to create and not have their data siloed inside services and applications. And then we started trying to visualize what this would be like, and it really was a mistake, a series of mistakes that led us to where we are now. That we started creating an app to essentially demo screens quickly that would look like basically, yeah, be mock-ups for what it would look like when we had interoperability and open protocols everywhere. And so this is what I'm going to show you. And recently we've been calling this, well, what if Excel could make apps? You know, what if it was really easy to build apps and you didn't need to be a developer? By the way, I'm not a developer. I studied art for 1 year and then just carried on my life, being excited about internet and freedom for people, really. So yeah, that whole idea, that what if I could email you an app and you could then play around with it immediately and you wouldn't need to compile it. It would just be there. It would be so things like it's no code. And yeah, this kind of harks back to Maggie Appleton's Barefoot Developers and that kind of idea. But like, I think just everyone that uses Excel should be able to make apps, you know, that kind of thing. And when we found there was a local first, we said, actually, we're doing that. It's an app. You know, we want users to own all their data and get it out of the silos and actually be in control of it. So it's what does it look like when that's the situation? And yeah, I can alter the screen. I can alter my interface as I'm using the app, just like I can do with Excel. And yeah, so there's a little bit of similarity there with Marek as well in that sense. And something not necessarily core, but I just want to say it anyway. AI second, you know, if you're driving along in your car and you're using your steering wheel, yeah, AI can use your steering wheel, but it can't get in the way of your steering wheel. You know, for example, you can always take back control, and that's a big thing for us. So we're kind of trying to coin this phrase, AI second rather than first. This is a very rough idea of where we are. In this part here, we're kind of like looking at the local storage and remote storage and synchronizing between this. It's a little bit locally firsty. Something that I'm really interested in here, which I'm really curious about, is what happens if the user interface was totally in control. The user using the particular app, was it totally in control of how the logic
Did
of the
anybody
data
else
was?
lose Daniel's audio? I don't hear Daniel anymore.
I can.
Okay.
I'm fine. Yeah, I can hear.
You can't hear me.
Yeah, me too.
I
Yeah,
can hear
I
him
hear
too.
you.
I can.
Oh, okay.
Who can? Can you hear me now?
Yes.
Yes.
Great. Perfect. Yeah. This idea of a semantic interface that basically is the logic of the interface that could then be re-rendered to the rules and preferences of the user using the app. So if they if there was a volume control, for instance, it could be a slider, could be up and down buttons, could be a knob, or that kind of thing. So what does that? I'm just fascinated by what does that mean to give the user that much control, you know? And this feels like a world away from fixed websites that we have now. And yeah, so I'm really fascinated by this kind of thing. So I'm going to give you a demo, and I've got some canned screens ready just in case the all falls apart. But other than that, I'll try and do it on the fly. So this is the front page of the app. It's app.kendra.io. It's available there. It's built using Angular. That's another mistake that it just happened because the EU project that we were funded by was what they were using, so that's what we used. So let's see. this when you hit the cog, that's your flow. So most pages are flows. They're not hard coded. So let's go to the flow cloud. So basically, so this is going to be a lot of information very quickly, but I'm sure you can keep up. So the flow cloud is where we store flows. Just refresh that. It doesn't resize automatically. And the flows are ideas of apps. And so first of all, I'm going to, and the flow cloud interface itself is a flow. So we can see things like it's logging into an API endpoint here. And there's a lot of mapping, and this is the definition of the data grid that you're seeing here. So if I were to find the header name title and I type something in it that's rubbish, and then I go down here and find the update button, then it changes the title there. So that's our kind of how malleable we want this to be. Obviously, this is only local, so I can just refresh it and it goes back to normal. Because the flow cloud itself, if I'm right, is something that is actually, I'm not even sure about that. So I'm going to not go down that road.
I'm going to jump in and ask a question.
Yes,
at this point,
please.
So you just showed editing the header of a column in a data table, and the editing was accomplished by updating a field in a blob of JSON.
Yes.
Is that the only interface for editing the user interface, or are there other ways that, say, would let you edit the title directly in that UI rather than going somewhere else and editing
absolutely,
some data?
that would be lovely. By the way, I should say, yes, you're quite right, Ivan. A lot of the no code, local first is, I should have said, is aspirational. What I'm showing you now is 5% along the road of what I was talking about. It's kind of like our very first foray into this. So yeah, ideally, yeah, you'd be able to, quite right, it's all JSON configuration in the blocks, in the action blocks, and you'd be able to edit them there or edit them actually on screen. Yes, that would be ideal. Yeah, Tom.
Yeah, follow up to that, like the programming model there, it's a sequential chain of transformations or something. So
yes.
Is there any like conditional logic? Can it be more than one split, or is it always like this one?
Yeah, so this is the set of things that we can add into a flow, and there's something called multiplex here that allows some of that to happen. Switch block also does a little bit of that. So, but really, again, these are, 5%. I personally speaking, I don't like this way of doing it. I'd much more like to see much more of the canvassy stuff that we've been seeing in terms of lines, being able to see it. So it's not a linear thing necessarily. It can be parallel, and you can see something a bit more like a Moog, where you're plugging into different functions like that. Okay, let's please do carry on chucking in your questions. So there was a thing called coronavirus that we all experienced, and here is a dashboard that we built for it. And at the time, we were plugging into real APIs. What you're seeing right now is has obviously been faked up a little bit. It's captured the status of the data as it was. But we created this by plugging into different screens. These are flows within flows. So I'm going to have to go to, this is our way of representing it. It's not, ideally you'd be able to use the same interface to then drill down into flows, but we're not there yet. So I'm going to show you one of these flows that correct, the global one, which is these two graphs here. And yeah, it's URL based at the moment. That's another discussion we're having. Do we want it to be like that way? Because if it's an app, it doesn't really make much sense. But yeah, there's more challenges to get over. So yeah, just this is the HTTP request that would have worked. In fact, we've just got all the data stored locally now, but it was a small change. Essentially, we kept the same flow. And
Okay,
there's
another one.
sorry, another
Yeah,
one. Go
another
for it.
question. Yeah, it looks really slick, right? So there's this composition of building blocks. Is there any way, how do you create like custom building blocks? I'm always like nervous when I've got like a limited amount of expressivity.
We haven't got there yet. What we're thinking about, that's a great question, because that's actually what we're grappling with. And there's so many questions like that is like, how do we build this in a framework that allows for expansivity? And so perhaps what we could do is can we mix hard-coded blocks and blocks that are created from other blocks? And can we mix that all in the same environment? And I think so that would be the way, because it's also about how do we develop this? We want to build this so it's as relevant as it possibly could be, as quickly as it could be. So build the most used blocks first. But then as people want more blocks, could we build a way that we could actually then build more and more fine-grained blocks that people could build that were much more computing elements, in a sense, that then people could build their own blocks. Obviously, the whole thing is on GitHub, and you could go and build hard-coded blocks as well. That's not a problem. But yeah, we haven't built a mechanism where that can then be put back into the code base, as it were. But yeah, that's something to grapple with. And I must say that I'm quite resistant to just allowing this to be TypeScript or JavaScript in here. I know it's possible. Well, it would kick us out of some security or privacy, gateways, as it were, like maybe to get into an app store or that kind of thing. If it was too general purpose and not sandboxed enough.
We got time for one more question. I'm going to bogart that last question, unless anybody wants to jump in and stomp on me. No. Okay. Do you
I'll
have
just show you.
Yeah, go
okay,
for it.
I'll just show you one thing, and that's. I just want to show you this. This is what I do. I changed that logarithmic to linear. Maybe you didn't see that, and I'm just going to update that so that changes the graph from logarithmic to linear. Okay, so go for it. Yeah.
Cool. Do you have a favorite task? There was that big window that popped up with all of those different tasks in it, if I understood correctly, when you click that add task button. I saw a bunch in there like multiplex and other things, and I'm curious if you have like a favorite one of those.
Well, I really like the one, and I'm cheating a bit here. I like the one that basically lets you go from a spreadsheet to a map or something like that. And it's basically, the one it is a Google spreadsheet. So we reference a Google spreadsheet, and then we're building this for a nuclear disarmament policy negotiator. And he wants to be able to see different kind of groupings of countries. And so I really like that one because, yeah, and here's the spreadsheet, and it's just and it's doing that live. But then we've built other systems. And how much time do I have, by the way?
Oh, we're at the end, but finish.
Okay, fine. Yeah. So that we've got other places where we've got spreadsheets, and then we import them. So you can connect live into spreadsheets. You can import the data into your local environment and then play around with it there. And then we can also, what we want to do is shove that data up to a hosted database, then have a Postgres database and front end it with Hazura GraphQL. And then we're talking Yeah, okay, I don't have that here, but we're talking GraphQL from the app. So I want this to be really flexible in letting people iterate over um, uh, different ways of doing things. So start really small, and then then you've got a fully blown database, and you're able to chuck this app to multiple people, and you're able to build collaborative shopping lists and that kind of thing. Whatever. Yeah.
Cool. We've gone from coronavirus to Caravaggio. That's a nice spread of data on display here. Yeah, cool. Kendra,
Okay.
I'm looking forward to seeing how that continues to evolve.
Cool. Thank you.
Yeah, thanks for the presentation.
Yeah, and please do drop me questions or anything anywhere. That's fine. Thank you.
Awesome. I have reset the clock. I'm gonna share my screen, and I'll start the clock running, and then we'll dive into the final presentation of the day, which is me showing a tool called Inkling. Is that screen share coming through? Gotta reorganize my windows. Great. Oh man, Zoom changed so many things, and now it's so confusing. Oh my goodness. Okay, there we go. I put that there. Okay, great. And then that's showing up. Cool and good and cool. All right, I'm going to start my time. We have two special guests on the call with us today, Alexandra Worth and Marcel Gatals. They're the two people who worked on this project with me at Ink and Switch, and they have full permission and encouragement to jump in at any time and shut me down and throw me into the sun. That's the privilege of working with me, is you can defenestrate me at any moment. Inkling is a little kind of experimental tool we made about a year ago as a sort of an evolution of a project we did earlier called Crosscut. And the way that it works is it's a little kind of app where I can write things. So I can say hello in here, and you'll see my fingers show up as these orange dots. Those are my fingers. And then there's a little tiny orange dot, which is my pen. And this is an app on iPad. So I've got, a pen and fingers that I can use for it. And I can also erase stuff that I write. What's cool about this program is if I do a little drawing, like let's say I make a circle here, I can tap this little ink splat in the top corner to enter a different mode we call meta mode, where you can take the things that you draw and add some dynamic behavior to them. So I've put a couple of handles on my circle over in meta mode, and now I can resize it and reposition it. If I draw a rectangle here as well, I can put some handles on it and resize and reposition, or maybe I'll move those handles around so I have, a better spot for grabbing those things. And not only can I resize and reposition stuff with my fingers using handles, but I can also make this thing called a gizmo. And a gizmo is a little graphical object that represents a geometric constraint. So I can kind of snap it onto my shape, because the little handles that we have here, I'll snap them all together. They like to snap, and when they snap together, they kind of all move together. But this gizmo with this special little symbol at the middle lets me express a constraint like a length constraint, or a length and angle constraint, making the whole thing very rigid, or just an angle constraint, which makes the thing act kind of like a slider almost, something like that. And once you have these constraints, you can start making little formulas for them. So you can say, hey, I've got length and angle are these two little variables that I've pulled out from that gizmo, and I can actually see their numeric value. So now I've got this little number, and I can use my fingers to scrub that number up and down and change the length, or pull out the angle and scrub that number up and down to change the angle. And so the way that we intend people to use this tool, or the thing we sort of happened into as we worked on it, was that it's sort of a little tool for making mechanical models. So here's an example of something called a quick return mechanism. So if I scrub through this thing, you'll see that the number that I'm scrubbing at the top right is connected to the angle of this little circular gizmo in the middle. It's going around in a circle, and that's kind of pushing and pulling these other gizmos so that, and I'll just drive it in one direction now, it moves quickly one way and then slowly the other way. and then quickly one way, and then slowly the other way. So this is a little simple machine that you can find, used in places where people use machines, that exhibits this behavior. It moves quickly, slowly. And we just built this little model really simply using these gizmos and formulas. An especially cool thing about this project is that it's all driven by a constraint system that is omnidirectional. This is a really cool thing. So if I have this little model of a solar system here, and I've got a little timeline at the bottom, and as I advance time, there's a little moon that goes around a planet, and the planet goes around a star, and it just goes as I crank time along. But I could also put my finger on the planet and crank the planet, and you see the slider moves down at the bottom. So that's kind of moving time. And it's kind of fuzzy, right? Like I don't have to stick strictly to moving around. I could like pull the planet in and out, and you might faintly see a little red line show up there. If I flip over to the meta mode, you'll see that red line connecting the star and the planet. That's basically the constraint system saying, hey, I'm uncomfortable. You're doing something that doesn't feel great. I have a length constraint and you're tugging on that length. But we let the user do that. We say it's okay to like physically override the constraints using your fingers. Feels good to do that. Gives you more expressivity and more play. And so not only can I crank that planet around and have that advanced time, but I can also grab the moon, and if I kind of wind it around the planet, now I'm also rewinding time, or I can go the other way and fast forward time. So it's really, yes, Marek, go ahead.
I was wondering, is this reactive programming or some kind of constraint solver?
It is a constraint solver. Alex Worth wrote a really nice, big, complicated, fancy constraint solving system that does a whole bunch of very cool techniques. For instance, if I have something like, here, let me just find a nice empty page I can demo this on. If I have a gizmo, as we call it, representing a constraint, and I say, I know what length this line is going to be. I've locked the length and I say, I know what the length is. If I also, actually, you know what? No, I'm going to say length and angle are locked. So that whole thing is a fixed length and angle. If I put my finger down on the one end and I move it, we don't even need the constraint solver to figure out where the other end is going to end up as I move it, because we know exactly where it has to be, because the length and angle are fixed. We can exactly compute the other end of that gizmo. And so the constraint system, what it does before it even runs the solving step, is it goes through and it figures out what are all of the variables that we can kind of collapse together and eliminate degrees of freedom from before we run the solver. And so it does this step.
About this solver, so how it would behave if you trained like 1,000 of them in a line?
Yeah,
would it be elastic or?
Go back here. So we have some demos of a bunch of, chained constraints, and I can kind of tug on both ends and it stretches them all out and it makes them all kind of uncomfortable. And then when I let go, they sort of snap back to the length that they want to have. So is that kind of what you were wondering, is like what it would behave like if you had a bunch of them chained together, or was that a different question?
So at this level, I still cannot see the property that I was thinking about. So this could be like inverse kinematic solver or something like that. But if you string like really, really a lot of them together, like 1,000 or more, then there are different classes of solvers. There are the ones which in one step give you the best optimal solution, and there are the ones which are just approaching the better and better, like slow relaxation.
Yeah.
So this is a more physical based simulation.
This is like an iterative relaxation based solver. So we're using gradient descent to slowly approximate the solution, right? Like to minimize error, essentially.
Nice. Cool, thanks.
Yeah, did that answer the question? Cool. Yeah, I have a bit more demo time left. I'll show one other cool thing that we've done in this prototype. Oh, why do I have, there we go. Apologies for the QuickTime overlay. There's an interesting kind of behavior going on here where I've got this handle that I can move around, and these two kind of glowing ones are pinned in place. So if I start pulling, the other one's going to resist moving. It's going to say, stay there. But this one in the middle that has, the length of these two middle ones want to add up and be 590. I can kind of scrub that value and say, let's make it 600. So the lengths of these two ones added together want to be 600. So I can kind of move it around and see, oh, okay, it's kind of making like an ellipse-like shape, sort of. But what I want to do is say, hey, move that little middle handle everywhere you can possibly go. Like try to go anywhere that you can possibly go and show me where you end up, right? Where does the constraint system make you end up? So if I hold 4 fingers and then I tap on that handle, we get a bunch of samples showing us, hey, here's all the places that it's going to end up. And as I move these things around, I get a kind of a real-time updating sort of preview of where it tends to want to go. And we could, make that circle look much more circular by cranking up the iteration steps that the solver does, but we kept it pretty low just to keep this performant, because this is, just experimental. And I can like adjust the sum of the two lengths and kind of see that the radius of this ellipse changes. And so that's some interesting behavior that we were playing around with when we were working on this prototype. That's about it for presentation time. Tom, you raised your hand. You gotta be rude, dude. You gotta jump in.
Yeah, it
and
was
say.
like 3 seconds ago. Yeah. No, this is really cool, right? Like I try. Sometimes I want to design a machine. Like let's say something simple, like a pair of scissors, and and you can have all kinds of weird interactions, like rolling joints. So it's not just a pin, or you have cams, and if they're a slightly different shape, you get a different motion profile and stuff like that. And you can kind of like envision, you kind of got to envision target motion profile, and then you've got to come up with like the simplest mechanism possible to realize that from the input motion, which for scissors it's like squeezing the things together. And like it seems like you're so close to being able to just go from that kind of like, I want it to look like this graph, and then like that is how close can you do that is my question.
Yeah, I mean, we don't have any sophistication about geometry in this system. Like we just quite literally have these raw constraints that are length and angle, and that's about it. They're sort of like representing a vector in polar coordinates. That's how all this stuff is modeled. So we don't have anything like, you could put in a profile and do some intelligent work based on that profile. But I mean, if I drew like let's say I drew the arm of a scissor here, and it had some like weird shape to it or something like that, and I wanted to position constraints on that specifically, I could like put some handles on it and say, well, the actual place that it's going to pivot is like right here. And then if I put a gizmo on that and then, hooked it up with something else, like some other, let's say the other arm of the scissor, if I put that like that, oh no, I broke it. Let's just say you could play around and maybe find something that would do what you wanted, but there's no assistance built into the tool to help with that. Yeah, John, you had a question also.
Yeah, so I mean, first of all, I guess I'm intrigued because like I'm actually like kind of working on something like very similar to this for my job right now. But like my question was, what like how expressive are the constraints? Like because like you showed like adding 2 things and saying equal to this. Like what kinds of things can I put in there? Can I have like arbitrary equations? Like what are the limits?
Alex, do you want to answer this?
Yeah, so we used to have a formula editor that was really expressive, and we have a way to compile some arbitrary expression that you might, enter into a constraint. The thing is, in order for this stuff to play nicely with gradient descent or relaxation or whatever, the thing needs to be pretty continuous. And so like, using a modulus or something would probably be a no-no. You can try it and sometimes it works well, but it's you want kind of these things are the arbitrary expressions that you can put in, they get compiled into error functions, and you're trying to minimize the error with the solver. And so you want to be able to take the slope of this error function, and you want that slope to be smooth, right? But if you can make it smooth, then you can do pretty much anything you want. So Marcel had built a really expressive formula editor that we had in the system, and we took it out just for this presentation that we had at the live programming workshop, because it was hard to get the recognition of your, like, you would write this with your hand instead of just like drag a thing in. And
Yeah, it was like a
wasn't
little handwriting parser. So you just like write, 5
right.
plus X plus 3 or whatever, and then bind X to something, for instance.
But yeah, if you're interested in the solver, I'm happy to talk about it offline. And we also put all the code online, so you can check it out.
Yeah, if you go to feelingisreality.com, that is the website where we have documentation for this project and a link to the GitHub page, feelingisreality.com.
I wanted to ask a question about if you had that one the line that was constrained by angle and by distance, by length. If you tried to twist it, would it go red? That one is, if you put a finger on both ends and then turn it.
So when
Why
we
doesn't
put a
that-
finger on both ends, and this works,
Yeah.
like, let me do the length constraint here, and I'll pull
Yeah.
out the length, and you'll see that
Yeah.
it's a darker value. There's like lighter values and darker values, or kind of like shaded values and clear values, show whether it's constrained or not.
Okay.
When I put a finger on both ends, a special behavior kicks in that says the user wants this one constraint to change. And that's going to override the setting that the constraint has. But if I put two of them together and say they're both going to have, I'm going to like wire both of them together and say now they have the same length and angle, and I start pulling on them like that, they get cranky.
Right.
If I change that to angles and start turning it, then I think they also get cranky when the angles change.
Yeah, so that stuff that Ivan just talked about is a design choice, right? We could have had it turn red if you try to overstretch a single gizmo, but we decided that it would be nicer for the user to interpret that as, the user wants to change this length.
So two things occurred to me. One is inertia in the kind of wanting to get back to it, like more springiness, so things would sort of oscillate, and then you've got all these oscillations going on, which would be quite funny. And then sort of gravity, or some things, like external forces, and being able to, that kind of thing, whirlwinds, whatever. I don't know.
Yeah, that stuff would be lots of fun to play with. And we're hoping to come back and do some more experiments with this kind of, gesture-driven constraint manipulation in the future. And more programmability would be, and more forces and physics and that kind of stuff would be a lot of fun to bring into this.
Right now,
I'm gonna
a wrapper.
Sorry?
I was just curious if you guys are going to release it as a PWA that just depends on like basic touch functionality rather than something Apple tech specific.
Yeah, the if you're looking at the GitHub page that says this ironically doesn't work on touch devices in the browser, even though it works on desktop in the browser or iPads with our special wrapper. Since then, we've actually changed the code base slightly so it does work. If you go to inkling.surge.sh, that's our kind of internal developer URL. No promises, buyer beware. That might break at any time. But if you go there, there's a little black dot that shows up kind of at the top in the middle. And that is a toggle that will control whether or not touches are interpreted as the pen or as fingers. Because that's the thing. This was designed for simultaneous 10-finger plus pen input. And you can't do that in the browser. So that's why we have to have that little Swift wrapper. But we made
cool.
a hacky version so that you can at least kick the tires on it without having the wrapper installed.
What was that URL
Yeah.
again?
Inkling.surge.sh, because the name of the project is Inkling, Inkling, and surge.sh, surge. Is just a nice, it's sort of like Netlify, but way faster and also super jank, like broken JPEGs on their homepage kind of jank. But it's very fast. I'm gonna call time there because we're at the top of the hour. I'm gonna stop screen sharing. I'm gonna say thank you to our 3 presenters today. That was a lot of fun, as always, and we'll do another one of these in a month or so.
Yeah.
Yeah.
I will put one
So
on
if
the
you-
Slack.
Yeah. And if you have a project you want to demo or something like that, by all means, jump in the thread and say, me, I'll show something. It doesn't have to be super fancy or visual or polished or anything. It can even just be like a provocation or a slide deck or a rant. Anything that you want to share is welcome. So thanks everyone for coming.
Yeah, thank you.
Open bar, drinks are on us. Help yourself and be sure to fill out the questionnaire, something jokes. If people want to stick around, thanks Alex for putting inkling.surge.sh in the chat. If people want to stick around and chat, there's nobody says you have to go home.
How was Splash, Ivan, for you?
It was, what the heck? I'm trying to, direct message. I'm trying to share a message to everybody in the meeting and it's giving me an error. There we go. Splash was fun. Live is starting to feel more and more like, hey, we don't have Strange Loop anymore, but we have live. So all the, weird interfaces and kind of, like things that would not necessarily have an audience in the more academic tracks at Splash are finding a good home in live. And so there's a lot of sort of provocative or unhinged ideas about ways we could reshape computing. So it definitely feels like, like a good home for the work that people in our community are doing. So yeah, like Michael, you shared CodeFlow. That was, I think, a perfect venue for that project, I think.
Yeah, and I loved sharing there, but also the other projects, very cool to see.
Yeah. Did anybody else here catch any of the talks at Splash? Have any favorites?
I was just trying to find the live conference. Actually, it's using a common word for the conference name. Why do they do that?
Yeah, it's not a great Googleable name. I think
YouTube somewhere.
I think in Linking Together we shared it. Let's see. Taylor shared it in Linking Together on Monday. So if you just scroll up a couple of chats, it's there. I think personal favorites from live. I'm Marcel, who's here, so I can only mildly besmirch him. Showed I'll be completely sarcastic. He showed a not at all provocative and totally boring and very dull visual programming project that had no interesting ideas and didn't do anything with graphic design as a way of expressing program behavior. Definitely not worth checking out. Boo. Yeah, no, that one was
That's
good.
what I was most curious about, actually. And I couldn't find it easily. I was trying to see more details about that, but I couldn't figure out where to find it.
Yeah, it's the first session. Here, I'll find I guess there was Jonathan Edwards' kind of opening keynote, which was a good, like, hey, here's, what we've been working on in this track all along and how that's been going. And then Josh Horowitz gave a very, very useful talk about different ways that live programming systems give users feedback, and like what are the different qualities that we can use to assess that feedback and understand it. And it's sort of a useful framework for thinking about how we could advance live programming in the feedback dimension as opposed to like in the input side. And then I've got Marcel's talk. Looks like it starts at about 2 hours and 32 minutes thereabouts. So I'll just share a timestamp link to that in linking together. There. Is that going to work? The embed going to work? Oh no, it's the curse of the bad embeds. Do you guys know about the 2 different embed formats that YouTube has? Where there's like, if you share a live video with the /live, whatever, it doesn't do the embed, but if you change it to like the V question mark thing, then it does work. Or the question mark V equals. Let's see. Let's see if that fixes it.
I liked Conrad's talk a lot, actually, on the onward.
Yeah. I did not see that yet. Sure, to onward, do we have a timestamp link to that?
I'll see if I can manage to find it this quickly.
Yeah. Yeah, there were a couple of folks from our community who shared stuff at Onwards as well. I know Andrew Blinn shared something. I think Cirrus gave a keynote somewhere. Cirrus Omar from like guys working on Livelets, I think. I think that's him. Type tolls, that stuff.
It was multiple days, so you have to also.
Yeah, and their website is quite hard to navigate. I found that unfortunate.
On the 25th at 65 minutes it starts, but
was there anything on end user programming? Was it mostly about coders coding and yeah?
Live had a little bit about spreadsheets, which are
really?
kind of get lumped in with end user programming. Like, hey,
Mm-hmm.
here are some novel ideas for spreadsheet interfaces. Like Taylor Trush, who was on this call earlier as a frog and then took off.
Right.
He showed a couple of prototypes called scrap sheets, where he has like game of life and that sort of thing implemented inside a spreadsheet interface.
Mm-hmm.
Ian Klester had a project called Tape that he showed at Live that also used spreadsheets as a motivating example of cases where you have a computation or a formula or something like that producing a value, and it produces that value in a context that sometimes you can edit the value manually and sometimes you can't. So in a spreadsheet, if you have a cell with a number in it, and that number has a bunch of decimals, you could just truncate it wherever you wanted. But if that number is the result of a formula, now you can't, right? Because it's a generated number. And so the interface kind of like makes a promise and then breaks the promise. And so he had a bunch of examples of that in a few different domains that felt sort of like, relevant for end user programming, where it's like, hey, if your UI promise is something, don't let the computation, the entrance of computation into that UI break that promise. I found that really compelling. I'd also say like Inkling, the project we showed is very much on the realm of end user programming. Like there's no if statements, there's no like, function calls or anything like that. It's a like a data modeling tool. It's a domain modeling tool. It's not for programming generally.
Right. Right.
I feel like many of the talks at Live are about making programming less traditionally like programmery, like less abstract, less theoretical, more tangible, more hands-on, like things that we usually associate with end user programming. So either they're making it more end user programmable, or they're just trying to tear down the distinction in a lot of cases, which I find really, really nice.
Tear it down.
Yes.
I have to go, so I see you next time, I think.
See you, Michael.
Bye-bye. See you
Bye,
later.
mate. Would you say there are other places where people are talking about end user programming a lot, or is that kind of the space, or this even the space? Are there other communities where they're kind of like focusing?
I've been talking a lot. Anybody else have a favorite
Anyone
watering hole on the internet?
Yeah, exactly. That's a good question. Okay, that's the answer.
All right, fine. I'll run my mouth a bit more. There's the Malleable Systems Collective. They have a discourse run by Ryan, who is normally here on these calls, but not here today.
Okay.
He was at Splash also. That was fun to see him. Of course, there's like Ink and Switch, where they have a Discord, though I think it's still invite only. I'm in it, but I don't know the deal with it. But sometimes there's talk of end user programming stuff in there, and some of their essays that they share are kind of tangentially aligned with that topic. I mean, there's another track at Splash. Is it Paint? I feel like they might have some end user programmy kind of stuff. What does Paint stand for again? It stands for something provocative, though I've always looked at their talks and have not really vibed with them. But let's see, programming abstractions and interactive notations, tools, and environments. Yeah. So that second half, interactive notations, tools, and environments, sounds very much like it would be, well aligned with live programming and visual programming and user programming. But it's, Oh yeah, there was a talk on that track this year that I wanted to watch. I have to go back and watch it, which is Advanced Game Engine Wizardry for Visual Programming Environments.
I literally just noticed this title and started like reading the article.
Yeah, I figured, Marek, that would be appealing to you.
That research group, I feel like it's the one I'm thinking of. They do a lot of interesting things. Are they behind Lively as well?
Oh, I don't know. That's a good question.
If it's the one
I mean,
I
like Lively, like the Smalltalk derived project, like Lively kernel, that thing.
Yeah, there's some European group, I've forgotten the name, and attached to some university. I think they're doing a lot of the recent work on it.
Are you talking about HPI?
Yes, it might be HPI.
In Potsdam.
Yeah, I
so
think you're
Robert
right. Yeah.
Hirschfeld over there had a lot of students doing Lively stuff. Lively was actually Dan Ingles' project. He's the implementer of Smalltalk. And at some point he decided he wanted people to use his stuff, so he did something similar on top of JavaScript with mixed results, unfortunately. Because it's kind of, as Peter at Think and Switch says, there's a lot of wetware required to use Smalltalk effectively, and so just porting it to JavaScript is not quite enough. But it was an interesting thing anyway. Oh, by the way, if you guys haven't seen it, there's a great demo that that Dan Ingles did with like a summer intern, Astrid, I think was her name, called TikTok, where there was one of the presentations here made me think of that today. And it was you would directly manipulate a bunch of objects on the canvas, like rotate something or move it. And the log of the things that you were doing was in a list of kind of tiles on the right of the page. And you could drag those tiles out of the list and use them to construct a program. And that seemed like a really natural way to discover things that the system can do for you, and later abstract the things that you did, into methods and functions and so
on. Just because this is kind of a cursed name, how do you spell that TikTok? Is it TICK?
I think
Or do you have a
so.
link?
I'm gonna look it up. Hang on.
Yeah, find it. Because I haven't seen this. That sounds cool.
Yeah, this is a really this was before TikTok, the social platform, was a thing.
Also, Rob Hirschfeld and Rob Heisfield. I don't know how to say his last name, but I always get them confused because it's like Rob H, right? No, there's two Rob H's, and they're both active in this space. And they're both, took me a long time to realize they were actually two different people.
So I'm going to post a couple of links. This is
posting them in, I see, TikTok.
This one that was posted is not what I was talking about, I think.
Oh, okay. Interesting.
Yeah, that wasn't it. This is a talk by Dan. I'm not sure if he talks about that particular system, but I'll find one right now and send it.
Oh, John Aldrich did this other TikTok. Interesting. Or was involved supervising, presumably. Keynote lessons learned, Dan Ingles. There we go. People mentioned Dan Ingles, Maria Montessori. Totally normal, YouTube. Cool. Well, that's going on my watch list. If I can figure out how to do that. Yeah, save. There we go. Watch later. Cool. Well, I'm gonna drop off, but feel free to hang out and keep chatting.
Yeah,
I think I can.
I'm gonna drop off too, but I'll find that video and send it to Ivan so he can share with everybody.
Yeah, or you can log into the Slack and share it. These are also available options.
Or I can do that. I will do that.
Let me guess which one's easier.
So
No, I'm happy to do that.
Alessandro, before you drop, I actually wanted to kind of pick your brain. So when you do this kind of relaxation, so do you have to do like the differentiation whenever the kind of structure changes?
So I have two flavors of constraint solver that I used in this project. One of them I wrote like from scratch, and the other one was leveraging this thing called uncmin that that a lot of people use. When I wrote my own, I did do the numerical differentiation. So the idea is you basically you take all these error functions that you have and you compose them into a bigger one that's the sum of the squares of the errors. And then you sample that, right? You say you're trying to figure out if you should nudge one variable one way or another way. And so you're basically taking the derivative of the global error function with respect to that one variable. So what you do is you measure the global error at the current value minus some epsilon and the current value plus some epsilon, and that gives you a slope, right? And you want to nudge that variable in the direction that eventually leads to an x-intercept, right? So that where the error is zero.
And okay, I wanted to ask you another question. So
automatic differentiation, though, is something that I've always wanted to use because it could give better results.
Oh yeah,
but I never
there are
got
like
around
tricks
to
to do this. So if you have like a formula, you just evaluate formula differently, and you have the differentiation.
Exactly, and that's kind of a beautiful thing. I read a bunch about it, and I wrote a couple of prototypes, but I didn't finish. So,
But I was also wondering about the behavior of those things, because whenever I do constraint relaxations, the way I approach this is I just go over each constraint and I like fix it. And this always leads to like every simulation is different, right? You add an extra node and suddenly the behavior of the whole system changes because like this extra constraint actually messes up with some very fragile mechanism. And this gradient-based approach, I guess it should be more stable.
it is a little bit, but it's still not great. The secret sauce in the prototype that Ivan was showing is really what happens before the gradient descent. So I took a lot of care. For instance, like if you have a gizmo that is pointing in one direction, right, and then you add, and it's the length is locked or something, and you add another gizmo on top of that that's pointing in the same direction with the length locked. You don't want those two length constraints to create like a stronger length constraint that's going to fight everything else. So that's one thing that I basically remove from the system from the start. Like the constraints that the user adds are not the constraints that are running. I kind of combine them and I figure out what duplicates exist.
Oh yeah, so you can even add weights. So one constraint could be more important than the others.
You could, if you wanted to, you could do that. And that would be a simple extension. I've done things like that in the past. This one doesn't do that. It does an all or nothing thing. Like if there is a length constraint between these two handles, it doesn't matter which direction. We treat it as a single length constraint. Another thing that we do that's pretty cool is I try to unify variables as much as possible. So a good example of this is like if you have like equality, for one thing, equality is not treated as a constraint in this system. It's treated as unification of variables, right? If I say the length here is equal to the length there, as far as the constraint solver is concerned, there's only one length variable. And then when the constraint solver tweaks the value of that variable, I distribute, I actually copy the same value to both things in the domain. That ends up being huge because constraint solvers don't like a lot of wiggle room. And so, like, you know, if for instance, while trying to solve something, there are two variables that are supposed to be the same, but they're not, and you nudge one variable in one direction, the other variable in another direction, it doesn't help the gradient descent get to a solution. So this kind of minimal model that gets created from the very kind of what should I say? I guess a very redundant thing that's built by the user. It really helps to minify that, like minimize it before you actually give it to the constraint solver. There's a cool thing that we do. It's really a generalization of equality. That's a linear equation constraint, and that is that it's kind of a y equals mx plus b, where m is a constant and b is a constant and m is not zero, right? So you can treat that as a kind of equality because you say basically there's really like the y and x are the same variable, but they're offset in certain
It's
ways.
just a scalar, yeah.
Yeah, and so you kind of, the arrow functions need to be able to talk about both, right? While the constraint solver is like iterating to find a solution. But there's really one piece of state only, not two, for those. So that also really helps. Another thing that helped a great deal was clustering. So Ivan went to a slide that had two chains of gizmos. Remember that? So those chains were disconnected and there weren't any constraints that were involving handles from both of those clusters. And so that means that we can separate them and solve those two clusters completely separately, right? Which also increases the stability of the system and all that stuff. So it's like a lot of care is taken to like make sure that the constraint solver isn't being pushed too hard. And then, because I had built a bunch of these constraint-based systems before, and none of them were as stable as this one. And it's because of these things that we do before gradient descent, more so than which gradient descent solver we're using underneath. And our approach is kind of pluggable in the sense that if you come up with a better gradient descent solver or you want to use relaxation instead or whatever, all of the stuff that we're doing before that solve step apply equally well.
Well, whenever I've been playing with like tactile user interfaces, like touch-based, the latency of this like gradient approach, it's amazing. So this is why I found it very interesting. The only case where I actually managed to get like a latency like that was when, obviously when you have like super simple objects, but also when I just had these, if you have just unidirectional relations, so one object can always influence one object, and
right.
You can get like a very simple chain like that, then you really don't need any sort of constraint solver, and in a single frame you can always find the optimal position. So this is something that used to
That
work
is kind of a
nicely
data flow
when I was
thing.
touching. Yeah, exactly.
So and that's but we do that quite a lot actually, right? When Ivan was talking about, you know, if this gizmo is length locked and angle locked, if you move this one handle, the other handle's position is completely determined by the position of that one, and vice versa, right? If you're moving the other one, you know the position of the first one. That's something that we call propagation of knowns, and everything that you put your finger on is known. And so from that perspective, what we're doing is a lot like data flow or like reactive, you know, programming models or whatever, because you basically, there's a, you know, it's still omnidirectional in the sense that you can drag either of these things and, you know, the other one will be determined by the one that you're putting your finger on. But it does, like, I guess you could say that we try to do as much as we can with data flow. And then what we can't do with data flow, we give to the constraint solver, right? So this is like, it reduces the number of dimensions that the constraint solver has to worry about. And I think that's one of the tricks that's really giving us a decent frame rate, like decent latency with the solver. We could also, there's another thing that you can do that's a little bit dangerous, but we've tried that before, like not in this prototype, but you can lower the tolerance, like you can increase the tolerance that you have for the, when you're trying to minimize the error in the system. You could say, well, I want the error to be less than 1,000th or whatever, which is, I think, what we're doing. But if you're not hitting the frame rate that you want, you could just say, well, I want the error to be less than or equal to 1 or something, and then that lets you do a lot of things. But sometimes you'll see that, as you drag things, constraints are clearly being broken in some ways, and then you let go and kind of things adapt later. Or like if you're, you know what I mean? Like you could, while you're doing a lot of manipulations, you could increase the tolerance, and then when you let go, you could lower the tolerance again so that it really hones in on the right thing. There's a bunch of stuff, but
So for the data flow, like how it can be by like flow in either direction, like does that mean like you have to essentially like solve their equation symbolically so that you can like solve in terms of like one variable or the other?
and
Present them
it
like a
doesn't
graph, so you flow
doesn't
from
mean
like one node in the graph to the rest of the graph.
yeah, so it doesn't mean that you need to solve, well, I guess in one sense it does mean that you need to solve it symbolically. What I did was there are a lot of these constraints, right? Like a length constraint, for instance. Let's see. No, length is not a good. If you have like, so the gizmos are really polar constraints in the sense that they have an angle and they have a length. And if you have both of those, like if you know both the length and the angle, and say the X and Y of one of the handles, what I essentially have is like, I have some code that will figure out what the value of the other X and Y are, right? Based on the ones that and vice versa. So I do have to implement it in both directions. There are other things, do you know what I mean? So each constraint, and the code is pretty well documented in this sense. I encourage you to take a look. There's an interface that I have to implement in order to add a constraint, to a type of constraint to the system. And so there are things like, how do you propagate known values, right? And this is something that the solver kind of calls, like we call this method before we make the solver do anything. And it's like, well, here's a set of variables that I already know the values of, and you can count on these not changing. And then what this method is supposed to do is it's supposed to set the values of any other variables that you also know the values of based on the things that you already know, right? So this is where like you need to implement the thing in both directions. Like if I know everything, like let's say a constraint is about 3 things. If I know 2 of them and I can solve for the other one kind of, with a closed form solution, then I'll do
But like
that.
what I hear you saying is that like your set of constraints is like carefully designed and limited such that like you can always like compute in both directions.
Yes, if you want to take advantage of that thing called propagation of knowns. But for instance, when we had the free form formula expressions that you could put in, that still worked. It's just that that constraint was dumber, right? That constraint did not know how to propagate known values. It only knew how to turn itself into an error function, which gives you like, it still works, but it's not as good as the stuff that's carefully
Gotcha.
selected and implemented from scratch. So I like the fact that you can kind of mix these two things and they'll all like play along, they play nicely together with varying degrees of niceness,
Yeah. So just to give you context, like I work on CAD software and we're basically making a programming language for it and like um there's I'm basically designing like a way to do constraints um in in that and so yeah, it's still sort of early design phase.
Yeah, take a look at our stuff, and if you want to talk, I'm happy to talk. Like there's a file called constraints.ts in there where like all of this stuff is done, and I'm sure like there will be things that are not good for what you're trying to do, and maybe there are some good ideas in there too that you can take. But yeah, I'm happy to talk about it.
Yeah, thanks. It's interesting.
No problem.
I better go and get some food. It's been really cool listening to all this stuff, and I'll introduce myself a bit better on the Slack tomorrow. See you guys. Thanks for everything. Been great to hear about all this stuff. See ya.
Yeah, thanks.
Well, I should probably get going too. We have a meeting at work, but it was great meeting all of you, and looking forward to chatting more in the future. Cool demos, by the way. That was really neat with the juiced objects, and yeah, that looked really cool.
Yeah, I wish we could have gotten the full presentation, you know.
I mean, we
Yeah,
can do
me
the full
too. It seemed like
presentation,
we were
right?
really time constrained. Like I got a really good vibe from the user interface, and I wanted to see some of the programming stuff as well.
Same.
So, and there is really not that much behind the scenes. I can show you. So, what are you interested in?
Well, I want to know the programming model, right? Like how you think about computation in your system,
Mhm.
how you think about states. There's a bunch of
Yeah.
stuff like that that would have been nice to see, but I think maybe on a future Wednesday, maybe there's time to do that now that you've shown some of the
So I actually
some
do
of the front ends.
live coding on Twitch. So if you
Oh,
manage to
neat.
find me on Twitch, sure.
Cool. I'll look you up.
But yeah, generally the idea is that it's really not complicated. I'm really not trying to design anything clever. It's just each object that you see on the screen is literally a C++ class with functions that can handle touch input and drawing and logic, right? Those are three separate things.
Right.
So
But
when I have
I
an
mean
object
that is a very like broad characterization of the thing, and there are lots of domains that you could create objects to attack these domains or whatever. And I'm very interested in finding out like what domains you've explored, what works well, what doesn't work well, all that stuff. But yeah, sadly I have to run, but I'm really looking forward to finding out more about what you're doing and seeing some examples and stuff.
Can
So
you
thank
post
you so
your
much.
Twitch link?
Oh yeah.
yeah, I'll write it in chat if I can open the chat. Okay.
Thanks.
Cool. Yeah, I need to get going also, but thanks everyone.
So long, everyone.